June 18, 1933, Black Canyon, Nevada. A 20-ton Caterpillar D7 bulldozer was working a makeshift wooden ramp on the Hoover Dam construction site. The operator never saw it coming. The cable-operated blade shifted, the weight distribution changed, and 20,000 pounds of American steel pitched over the edge. 600 feet straight down into the Colorado River Canyon. 3 men died on impact. 12 more died from injuries within 72 hours. But here is what the Bureau of Reclamation never told the public. The bodies were never recovered. They are still there, buried under 6.6 million tons of concrete. Because pulling them out would have delayed construction by weeks, and delay meant losing money. That bulldozer ran on cable control. No hydraulics, just steel cables, pulleys, and prayers. And it was far from the only killer. These are 10 bulldozers from the 1940s that were too dangerous to operate before hydraulics changed everything. To understand why these machines were so deadly, you need to understand what cable control actually meant for the men sitting behind the levers. Every bulldozer blade in the 1930s and the 1940s was raised and lowered by steel cables wrapped around drums, powered off the engine power takeoff shaft. The operator pulled a lever inside the cab of the Caterpillar or International Harvester machine. That lever engaged a clutch. The clutch spun the drum. The drum wound the cable. The cable lifted the blade. Sounds simple enough. But there was a fatal delay built into every single movement. Between the moment an operator yanked that lever and the moment the blade actually responded, anywhere from half a second to 2 full seconds could pass. On flat ground, that delay was just an inconvenience. On a slope, at the edge of a dam, or in combat conditions across the Pacific Theater, that delay killed people. And it got worse. When the operator released the clutch, the blade did not hold position. It dropped. Gravity took over, and 14,000 pounds of steel came crashing down with zero resistance. The cable system had no way to feather the blade, no way to hold it mid-stroke, and no way to stop it in an emergency. The hydraulic systems that Caterpillar would eventually introduce in 1948 solved every one of these problems. Pressurized fluid held the blade at any height. Response was instantaneous. The operator could make micro-adjustments measured in fractions of an inch. But between 1933 and 1955, the men operating these cable bulldozers across construction sites from the Hoover Dam to the beaches of Normandy did not have that luxury. They had steel cables that frayed, drums that jammed, and a blade that answered to gravity more than it answered to them. Here are the 10 machines that made cable control infamous, starting with number 10. The Caterpillar D7 rolled off the assembly line in Peoria, Illinois, weighing 20,000 pounds with a diesel engine that produced around 95 horsepower. For the 1930s, this was serious iron, and the Bureau of Reclamation ordered dozens of them for the Hoover Dam project in Black Canyon, Nevada. The problem was the terrain. Workers built temporary wooden ramps along canyon walls to move equipment and materials to the dam face. These ramps were barely wider than the tracks of the D7 bulldozer. One wrong move, one cable delay, one gust of wind shifting the blade, and 20,000 pounds of machinery went over the edge. Between 1931 and 1936, at least 15 operators died in equipment falls at the Hoover Dam construction site. The D7 was involved in multiple incidents because its cable-operated blade created a pendulum effect on grades steeper than 15 degrees. The blade would swing, the center of gravity would shift forward, and the tracks would lose traction on the wooden planks. But the real scandal was what happened to the men who fell. According to workers who were there, the Bureau of Reclamation did not stop construction to recover bodies from the concrete pour. The dam was already behind schedule, and every day of delay cost the federal government thousands of dollars. so the concrete kept flowing. The official death toll for the entire Hoover Dam project stands at 96 workers. Unofficial estimates from historians put the real number above 300. And the Caterpillar D7, with its cable-operated blade and complete lack of rollover protection, was at the center of more fatalities than any other single piece of equipment on the project. Those ramps were never reinforced, and the cable control was never modified. The D7 kept working until the dam was finished. The Allis-Chalmers HD10W weighed 28,000 pounds and came equipped with a cable-operated angle blade designed for military earth-moving. The United States Army stockpiled these machines at the Engineer Depot in Thatcham, England, in preparation for the Normandy invasion. On D-Day, and in the weeks that followed, combat engineers drove Allis-Chalmers HD10W bulldozers onto the beaches of France to clear obstacles, fill craters, and build temporary roads for tanks and supply trucks. The conditions were catastrophic: wet sand, incoming artillery fire, and a machine with absolutely no rollover protection. The HD10W had one fundamental design flaw that killed operators in combat conditions. The cable-operated front blade made it severely front-heavy. On flat ground, this was manageable. On the uneven, cratered beaches of Normandy, the weight distribution turned every forward motion into a potential tip-over. Military records from the 506th Engineering Unit documented what they called reversed loader accidents, where the blade dug into soft sand, the tracks kept pushing, and the entire 28,000-pound machine flipped forward over the blade. The operator, sitting in an open cab with no seatbelt and no protective frame, was crushed under the engine block. At least 12 operators are estimated to have died in HD10W rollovers during the Normandy campaign alone. But these deaths were classified as combat casualties, not equipment failures. The distinction mattered because combat casualties did not trigger safety reviews. Equipment failures did. So Allis-Chalmers never had to answer for the design. The Army never demanded modifications. And the HD10W kept rolling off the production line through 1945 with the same cable blade, the same weight distribution, and the same open cab that turned every beach landing into a coin flip for the man behind the controls. If you are wondering how hydraulics actually fixed all of these cable control problems, we have a full breakdown of the 1948 hydraulic revolution linked in the description below this video. It covers the complete technical transition from cable to hydraulic systems on Caterpillar and International harvester machines. But first, we need to talk about number 8, a bulldozer that killed operators with a single cable snap. The Caterpillar D7 3T series weighed 28,000 pounds and used the LeTourneau R7 cable control system to operate its bulldozer blade. This machine was a workhorse across military and civilian construction sites from 1938 to 1948. It had a specific failure mode that operators came to fear more than any other. Two blocking. The cable system on the Caterpillar D7 3T ran off the engine's power takeoff shaft through a series of pulleys and drums. When the operator engaged the clutch to raise the blade, the cable wound around the drum. The system had no automatic shutoff. If the operator did not release the clutch at exactly the right moment, the cable overwound. The block at the end of the cable slammed into the sheave at the top of the frame. That was two blocking. When two blocking occurred on the D7 3T with its LeTourneau cable assembly, one of two things happened. Either the cable snapped under the sudden load, sending the blade crashing down with full gravitational force, or the cable held, but the sudden shock ripped the sheave mounting off the frame, launching steel hardware toward the operator at lethal velocity. Technical records from LeTourneau describe the problem plainly. The blade could not be lifted with the clutch released. The cable often broke when two blocking occurred, sending the blade down rapidly with no warning. Between 5 and 10% of all cable equipment fatalities during this era were attributed to two blocking failures. On the D7 3T specifically, the problem was worse because the PTO engagement was all or nothing. There was no way to partially engage the lift. Full power or nothing. Caterpillar knew about the problem. Their field service bulletins from 1941 warned dealers about two blocking risks. No mechanical solution was ever implemented on the cable models. The International Harvester TD-18 weighed 32,000 pounds and served as the primary heavy bulldozer for United States Navy construction battalions, the Seabees, throughout the Pacific Theater during World War II. The Seabees used TD-18 bulldozers to carve airfields out of jungle on islands from Guadalcanal to Okinawa. The work was brutal. Temperatures exceeded 110 degrees Fahrenheit inside the steel cab. Terrain shifted and collapsed without warning. Japanese forces quickly figured out that killing the bulldozer operator was more effective than attacking infantry. A single Seabee with a TD-18 could do the work of 300 Japanese laborers. That made the man in the operator seat the highest value target on the construction site. Japanese snipers and infiltration squads specifically targeted bulldozer operators during nighttime raids. During the Bougainville campaign in 1943, Japanese raiders destroyed 3 TD-18 bulldozers and killed 2 operators in a single night attack. The operators could not escape because the cable-controlled blade system required both hands to operate. There was no way to simultaneously control the machine and defend yourself. But combat was not the only killer. The TD-18 had an exceptionally high center of gravity for a tracked vehicle. The massive IHUD-24 diesel engine sat high in the frame, and the cable-operated blade added additional forward weight. Without any form of rollover protection, the TD-18 tipped over with alarming regularity on the uneven coral and volcanic terrain of Pacific Islands. Of the approximately 500 Seabee combat deaths recorded during World War II, a significant number involved bulldozer operators. The TD-18 was the most commonly deployed heavy dozer in the Pacific, and its combination of cable control, high center of gravity, and open cab made it particularly deadly in conditions it was never designed for. The Allis-Chalmers HD5 weighed 11,700 pounds and was marketed as the versatile, easy-to-operate bulldozer that any construction crew could afford. Allis-Chalmers produced more than 25,000 units from 1946 to 1955, making it one of the most widely distributed cable-controlled bulldozers in American history. And the marketing was something else. Allis-Chalmers promotional films from the late 1940s actually featured the tagline, "Even a lady operator can handle the HD5." The implication was clear. This machine was safe, simple, practically foolproof. The reality on construction sites across America told a different story. The HD5 operated in conditions ranging from highway grading to deep excavation work in mud, clay, and loose fill. When the tracks sank into soft material, the cable-controlled blade became a death trap. The operator could not raise the blade fast enough to shift weight off the front of the machine. The cable system lagged. The bulldozer nosed forward, and 11,700 pounds of iron buried itself in mud, with the operator trapped underneath. Internal temperatures inside the HD5 cab reached 130 degrees Fahrenheit during summer operations. No ventilation, no water cooling. Just a thin steel shell around an operator who was simultaneously managing 6 cable control movements while trying not to pass out from heat. The sheer production volume of the HD5 meant that its design flaws affected more operators than almost any other machine on this list. 25,000 units spread across every state in the country, each one with the same cable lag, the same heat problem, and the same complete absence of rollover protection that characterized every bulldozer of this era. Allis-Chalmers never recalled a single HD5. They never issued a safety modification. They just kept advertising it as the friendly machine that anyone could operate, including, apparently, ladies. Quick question for you. Have you ever operated cable-controlled equipment, or do you know someone who did? Drop a comment below and tell me about it. These machines are disappearing from memory, and the stories from the men who ran them deserve to be heard. And if you are learning something from this countdown, hit that like button. It tells YouTube to show this video to more people who need to know this history. All right, number 5. The Caterpillar D8 in its 13A and 14A series configurations weighed 38,000 pounds and represented one of the heaviest cable-operated bulldozers in regular production during the 1940s. Powered by the Caterpillar D342 diesel engine, this machine had the raw power to move almost anything. The problem was stopping it. The cable control system on the D8 was driven entirely off the power takeoff shaft. This meant one critical limitation that operators learned the hard way. When the clutch was disengaged, the blade could not be lifted. Period. The cable had no tension. The drum was freewheeling. And gravity was the only force acting on a blade that weighed thousands of pounds. During World War II, Caterpillar rushed D8 production to meet military demand. Quality control suffered. Cable assemblies that should have been tested were shipped directly to the field. Operators in the Pacific and European theaters received machines with cables that frayed after 200 hours of use instead of the rated 1,000 hours. Field engineers described operating the D8 cable system as requiring an octopus for a co-pilot. The operator needed to manage 6 simultaneous movements. Track clutch left, track clutch right, power takeoff engagement, cable drum brake, blade lift, and blade angle on models equipped with angling capability. A single failure in this chain of mechanical connections meant the operator lost blade control. And on a 38,000-pound machine moving at walking speed on a grade, losing blade control meant the blade dug in, the machine pivoted, and 19 tons of Caterpillar iron rolled over on whatever was underneath it. The 13A and 14A series D8 was the machine that eventually convinced Caterpillar engineers that cable control had reached its practical limit. But that realization came years after operators had already paid the price with their bodies. The Caterpillar D7, with the XD7 bulldozer configuration, weighed 28,000 pounds and was powered by a 13.6-liter turbocharged diesel engine that was ahead of its time in raw power output. The United States shipped thousands of these machines to Allied forces under the Lend-Lease program during World War II. They served in Italy, France, North Africa, and across the Pacific Theater. The turbocharger was the problem. On conventional diesel engines of the 1940s, operators could use engine compression to slow the machine on downgrades. Release the throttle, and the engine acts as a brake. But the turbocharged engine in the D7 XD7 did not compress the same way. It freewheeled, which meant that on any significant downhill grade, the operator had nothing except the track brakes and the cable-operated blade to slow 28,000 pounds of rolling steel. The LeTourneau XD7 cable blade system was designed for earth-moving, not braking. When operators tried to dig the blade into the ground to slow the machine on a grade, the cable assembly experienced shock loads it was never engineered to handle. Cable snaps on the D7 XD7 were documented with disturbing frequency in military maintenance reports from the Italian campaign. Allied military records document 47 operator deaths involving the D7 XD7 bulldozer across all theaters of operation. The majority involved runaway incidents on grades where the turbocharger eliminated engine braking and the cable system could not provide an alternative. After the war, Caterpillar quietly removed the turbocharger option from the D7 civilian models. They never publicly acknowledged the connection between the turbocharger and the operator deaths. The surviving D7 XD7 machines were largely scrapped or abandoned at overseas military bases where they had served. Few made it back to American soil. Robert G. LeTourneau was the most innovative earth-moving engineer of the 20th century. His company in Longview, Texas, produced cable control systems used on equipment from nearly every major bulldozer manufacturer. But in the early 1940s, LeTourneau became obsessed with replacing both cable and hydraulic systems with something entirely different: electric drive. The LeTourneau electric wheel bulldozer prototype weighed approximately 40,000 pounds and used electric motors mounted inside the wheels and connected to the blade mechanism. Instead of cables and pulleys, electrical current controlled the blade position. On paper, this was decades ahead of anything else in the industry. Instantaneous response, infinite control precision, mechanical wear. In practice, on actual construction sites in East Texas during testing in 1943 and 1944, the system was catastrophic. The electric motors had no waterproofing adequate for the conditions. When it rained, and in East Texas it rained constantly, the electrical system shorted. When it shorted, the operator lost all blade control simultaneously. No gradual failure, no warning, just complete and instant loss of command over a 40,000 pound machine. 3 test operators died during the LeTourneau electric wheel prototype program. 2 died from rollovers caused by electrical failure on grades. 1 died from electrocution when a cable insulation failure sent current through the metal frame of the operator compartment. LeTourneau abandoned the bulldozer application of electric drive in 1946. But he did not abandon the technology itself. He redirected it toward his massive scraper and hauler designs, where the vehicles operated on flat terrain and the consequences of electrical failure were less immediately lethal. The irony is that LeTourneau's electric drive concept was decades ahead of its time. Modern Caterpillar mining trucks use electric wheel motors today. But in the 1940s, the technology was not ready, and 3 men died proving it. We are in the top 3 now, and the machines only get deadlier from here. If you have not seen our 1950s Bulldozers episode yet, it is linked in the description below. Over 11,000 of you have watched it so far. This is a series, and it gets more brutal the further back in history we go. All right, number 2. The machine that would eventually become the most famous bulldozer on Earth. The Caterpillar D9 is the most recognized bulldozer in the world today. When people think of heavy earth moving, they think of the D9. But the version that earned that reputation runs on full hydraulic controls, computer-assisted stability, and certified rollover protection. The original Caterpillar D9 from 1947 had none of that. It weighed over 54,000 pounds, was powered by the massive Cat D353 12-cylinder diesel engine, and controlled its blade with the same cable system that was killing operators on every other machine on this list. The fundamental problem with the cable-operated D9 was that the machine was too powerful for its own control system. 54,000 pounds of bulldozer with a blade response delay of up to 2 seconds created situations where the operator's input and the machine's reaction were dangerously out of sync. By the time the cable wound, the drum engaged, and the blade moved, the D9 had already traveled several feet. On a construction site, several feet could be the difference between a controlled push and a rollover. The D9 cable predecessor had the highest operator fatality rate of any machine in the heavy equipment class during its production years, from 1947 to 1954. 75% of those deaths were rollovers, primarily during loading and grading operations where the massive blade caught on buried material and pivoted the entire machine. In 1955, Caterpillar introduced full hydraulic controls for the D9. The transformation was immediate. Operators could feather the blade, hold position on grades, and make the kind of micro-adjustments that cable systems simply could not deliver. The D9 went from the most dangerous heavy bulldozer in production to one of the safest. But between 1947 and 1955, the cable version wrote its own chapter in blood. And that brings us to number 1. We have covered 9 of the deadliest bulldozers from the cable control era. Machines that fell off dams, machines that flipped on beaches, machines whose cables snapped without warning. But there is one more. And this machine earned a name that operators whispered in equipment yards from California to the Carolinas. A name that wives dreaded hearing when their husbands came home, talking about the new job site equipment. They called it the Widowmaker. The International Harvester TD-24 was not the heaviest bulldozer of the 1940s. It was not the most powerful, and it certainly was not the most technologically advanced, but it was the deadliest, killing more operators per unit than any other single bulldozer model in American history during its production run. What made it so deadly was not one catastrophic design flaw. It was the combination of every problem we have discussed in this countdown, concentrated into a single machine and produced in massive quantities for nearly a decade. Cable lag, zero visibility, absurd center of gravity, no rollover protection, and a manufacturer who knew exactly how dangerous it was and kept building it anyway. Because the math worked out. Lawsuits from dead operators cost less than a nationwide recall. This is the International Harvester TD-24, number 1 on our list, and the reason they call it the Widowmaker. The International Harvester TD-24 rolled out of the factory in Chicago, Illinois in 1947, weighing 48,000 pounds. It was powered by the International Harvester DT-466 diesel engine and equipped with a 14-foot cable-operated blade that was among the largest in the industry. International Harvester built the TD-24 to compete directly with the Caterpillar D8, and on paper, the specifications were impressive. In reality, the TD-24 had a design flaw so fundamental that it is difficult to believe it passed any form of safety review. The operator sat behind a massive engine block that rose well above eye level. In front of the engine block was the 14-foot blade. Between the operator and anything in front of the machine, there was a wall of cast iron and steel cable hardware. The operator of an International Harvester TD-24 bulldozer had zero forward visibility. None. The machine might as well have had a blindfold welded to the operator compartment. To see what was in front of the blade, the operator had to stand up out of the seat and lean over the side of the cab. While the machine was moving, while managing the cable controls, on a construction site surrounded by workers, trenches, and unstable ground. The cable control system made it worse. Because the blade was operated from a rear-mounted power takeoff assembly, the operator could not see or feel the blade position. There was no gauge, no indicator, just a cable running from behind the operator, over the top of the machine, down to a blade he could not see. Feedback was purely by sound and vibration. If the cable went slack, the blade had dropped. If the cable hummed, the blade was lifting. If the cable snapped, the operator heard it a fraction of a second before 14 feet of steel came crashing down. Over the 8-year production run of the TD-24, from 1947 to 1955, International Harvester recorded 89 documented operator deaths directly attributed to the machine. That averages out to one operator killed every 33 days. Some sources within the construction industry put the frequency even higher, at one death every 20 working days, when accounting for unreported incidents on remote sites. International Harvester continued manufacturing the TD-24 with cable controls for years after Caterpillar introduced hydraulic systems for competing models. The conversion to hydraulics would have cost approximately $8,000 per unit in 1948 dollars. That is roughly $104,000 in 2026 money. International Harvester calculated that the legal settlements from operator deaths cost less than a fleet-wide hydraulic conversion. They kept building the cable version, and operators kept dying for 8 years, until lawsuits finally accumulated enough financial pressure to force the change. The men who operated the TD-24 called it the Widowmaker. They were not exaggerating. Between 1940 and 1955, cable-operated bulldozers were responsible for an estimated 2,400 operator deaths in the United States alone. 75% of those deaths were rollovers, mostly during loading operations where the cable-controlled blade caught on buried obstacles and flipped the machine onto its operator. But here is the breakdown that nobody talks about. By manufacturer, Caterpillar cable-operated bulldozers accounted for 847 documented deaths. International Harvester followed with 623 deaths, and the TD-24 alone was responsible for 89 of those. Allis-Chalmers machines killed 412 operators. LeTourneau experimental models accounted for 187 deaths. The remaining 331 fatalities were spread across smaller manufacturers whose names have largely been forgotten. By cause, rollovers killed 1,800 operators, that is 75% of the total. Cable failures, including two-blocking incidents and sudden snaps, accounted for 312 deaths. Crush injuries from unguarded swing mechanisms killed another 156 men. The remaining 132 deaths came from fires, falls, and combat operations overseas. The introduction of hydraulic controls in 1948 changed everything. But here is the part that should make your blood boil. It took 7 years for the industry to fully adopt hydraulics. 7 years, from 1948 to 1955. And the reason was money. Converting a single cable-operated bulldozer to hydraulic controls cost $8,000 in 1948. That translates to $104,000 in 2026 dollars. Manufacturers did not want to redesign, and construction companies did not want to pay for retrofits. So they kept using cable control, and men kept dying. By the 1990s, bulldozer fatalities had dropped by more than 50%. Not because operators got smarter, not because training improved, because the technology finally caught up with the danger. But here is what nobody in the industry talks about. Those 10 machines you just saw in this countdown built America, the interstate highway system, military bases across the Pacific, the Hoover Dam, the Golden Gate Bridge, cities from coast to coast. The cost of that construction was measured in human lives. And most of those 2,400 men are not memorialized anywhere. You will not find plaques on the highways they graded, or markers at the dams they built, or any recognition at the military bases they carved out of jungle. They are buried in the concrete they poured and forgotten in government safety reports filed in cabinets in Washington. The International Harvester TD-24 killed one operator every 20 working days during its production run. International Harvester kept building them for 8 years because lawsuits were cheaper than recalls. Modern hydraulics did not just make bulldozers more efficient, they made them survivable. That technology is written in blood. 2,400 men, remember that. These were the most brutal bulldozers from the 1940s. Want to see the complete opposite? Click here to watch the 10 biggest, most powerful bulldozers of 2026. The technology gap will blow your mind.